All right, number 10. So we have a graph. We're going to use the techniques of shifting, compressing, stretching, reflecting, and then we're going to find the domain and range of the graph. Okay, so we have 1 over x, which is the reciprocal function we see here. This 4 is in the position of b. It is with the x, okay? These functions look a little bit different when you're trying to identify a, b, c, and d. With a reciprocal function, it would look like this. Y equals, if the number on top was different, that would be your a value, and then your b, x minus h, like this, and then your plus k would be separate like this. So for example, if I had like a 5 and then a 4x minus 2 and then plus 3, this would be the visual that you would get for your a, b, h, and k. All right, so that 4 that we have at the bottom is b. It's b. And what b does is it compresses it horizontally. So it just squeezes my graph in, squeezes it down. And it's kind of hard to see that visually. I will try to give you a picture of that here on the graph. If I go to y equal, I'm going to clear what I have. So the first one I'm going to do is 1 divided by x. And I'm going to graph it. So you're getting just right up against the horizontal. You can't hardly see those lines. It's very, very small. And then if I go back to y equal and I graph this new function, be careful when you're graphing fractions in the old 83. You need to put the whole numerator in parentheses and the whole denominator. It's just good practice. So I'm going to do 1 in parentheses divided by 4x in parentheses, and then graph it. And all you do is see 2 little squigglies. Hard to see. Now what I'm going to do is I'm going to zoom in. So I'm going to go zoom and option number 2. So zoom in. Now there's a cursor blinking. You can't see it. I'm going to move my arrow pad up and down. See that cursor? But wherever you have that cursor blinking, which I want it on the center, that's where it's going to zoom in. I want to zoom in on that spot. So I'm going to hit enter right there. And that's the original function, and then that's the new function. This is a lot closer to the axis as compared to the original. So it just got squeezed all the way down. So compressed in that horizontal direction. And the graph that most resembles a compression, these B and C are totally different. That one looks further out as compared. This one looks a lot closer. So A would match. All right, we want to know the domain. So we got a fraction here. So what would make the bottom 0? We can solve, or you can just compare to the original. When you have the reciprocal function or the 1 over x right here. The domain is from -infinity to 0, and then 0 to infinity. So we don't get that point 0. And since our graph has not shifted left or right, we get the same domain. Okay. That will give us -infinity to 0, and then 0 to infinity. And then we check. And then we want to find the range. And our range will be the same because, again, this did not go up or down in any direction as far as vertical shift. And our range is the same as our domain. We don't get that point 0 in there. So -infinity to 0 and 0 to infinity. So -infinity 0 union 0 to infinity.